Good morning, my name is Kenneth Chiu, and today, together with our demo team, we are here to showcase some of the technology systems, namely CAD grade control on E-Series excavator and 3D AccuGrade on track-type tractors. Technology sometimes seems like a big word, especially in the construction industry. The word technology may sound complicated or even scary. Therefore, CAD Connect marketing framework was created to simplify our technology messaging by grouping all CAD technology systems into four value verticals, namely equipment management, productivity, safety, and sustainability. Our demonstration today will focus on how CAD Connect can provide an extra edge on and beyond our machines, and how this proven and existing technology can change the way our customer work. What you're about to see is two of our 320E excavators working on a trench, and its designs is as follows. They will start off with a regular trench of length 5 meter by 1 meter depth, followed by a 10% slope for another 5 meters. The purpose of this demo is to showcase that with added capability, not only is our machine the most fuel efficient, it will experience less idle time. The machine nearer to us is our 320E CAD grade control excavator equipped with CAD depth and slope function versus that of another 320E excavator without CAD grade control, working on the same job profile with the help of a grade checker who is waiting with a GPS rover. The second setup, without the aid of technology, let's call it the conventional method, is very close to what our customers are doing on a daily basis. Let's get straight to the action, and I will provide more information along the way.
3, 2, 1, start!
There they go. We have started the timing on this screen so that we can keep track of the time difference between the two setups. This timing is needed for us to do a competitive comparison at the end of this demo. Don't worry too much about multiple screens and displays. I will direct your attention to the screen and that I would like to focus throughout the demo. Allow me to repeat again. The machine closer to us is equipped with CGC. Therefore, he is very confidently digging as he knows exactly where his bucket position is with respect to the reference set point. Also, he is aided with a laser transmitter that is providing him with an elevation reference. This laser transmitter is rotated at 600 RPM, meaning 10 strikes per second, providing reliable, precise reference for up to millimeter accuracy. So, how does the operator get her reference from the conventional method? She has to rely on extra markings marked earlier by our diligent grade checker, and also requires the checker's assistance throughout her trenching work. We, Caterpillar, make the best machines. We have results from numerous production studies done against competition all over the world to prove it. We have 320E or even D-series excavator that has been proven to be the most fuel efficient machine in the market. As long as we allow our machines to perform, we know that we are going to move dirt effectively and lots of them. However, what we and our valued customer cannot control is when the machines are idling at the job site. Nothing is wrong with our machines or operator. It is just external factors like lost grade sticks or waiting for grade checking that stalls the operations. An idle machine can never be the best machine out there. Some industry experts say that it is not unusual for idle time to represent as much as 40 to 50% of the total running time of the machine. Isn't that surprising? Why are they idling? Waiting for setup, surveying, quality issues, over or undercut, repeated reworks, waiting for grade checker to set up references so that we can achieve our desired designs? So apart from focusing on being productive, perhaps it is equally critical that we look at reducing idle time at the job site too. So let's see if our 320E CGC machines are designed and built to be smart enough to help us reduce idle time significantly, allowing our machine to perform its duties. From where we are, you may not be able to see clearly the markings on the ground. This screen shows the layout. We have marked extra reference so that the operator and grade checker can reference to do checks along the way. Even with such a simple design, we have to do a number of extra references for the machine without CAD grade control. In most job sites, the designs are much more complex, involving curves, slopes, and changing grades. As the desired designs get more complicated, the intensity and requirement of grade checking will increase exponentially. This video is taken during our rehearsals. Each time we start a job, our hardworking and dedicated grade checkers have to prepare the ground. In every job site, in order for our machine to start working, we will see large number of grade checkers running up and down the job site to mark out required reference points for the machine and surveyors. A lot of time is spent to prepare the ground. This is precious working time on site with good and permitting weather condition, but machines are parked up, just waiting to move in and could not do anything to get the job done. Also, as the designs get challenging, staking out becomes challenging too, increasing in difficulty and fatigue on our surveyors, thus increasing the risk of errors in measurement. Now we know why reworks, inaccurate staking are so common, such that large amount of idle time is widely accepted in the job sites. Notice that our best-in-class machine 320E excavator stops and calls for the grade checker to come in. That's idle time. She has to stop and allow our grade checker to come in to check on her work. The tolerance required for this demo is plus or minus 5 centimeters, which in my opinion is quite generous. So if the grade checker finds that the profile is out of tolerance, she will inform the operator to reshape the trench until she gets it right. In short, in conventional method, the machine is only as fast as the grade checker goes. Maybe you will ask, how often do we require a tolerance of plus and minus 5 centimeter? It may not be reasonable at all. That is absolutely not true. Allow me to quote an example. Let's say we have a contractor that plans to do a drainage from one side to the other. For practical and space reasons, he is required to dig a trench of 2 to 5% grade. These grades are completely not visible to naked eye. Furthermore, 1% over 100 meters is 1 meter height difference. I'm not sure how often we will have the luxury of a 1 meter height difference. Also, the gradient along the entire trench is critical for the flow of fluid. A slight mistake in grade along the way will result in the fluid unable to flow out and get trapped in the middle of the pipe, which is disastrous. In fact, how many times have we heard about drainage backflowing due to wrong grades? So what does E-Series CAD grade control consist of, and what are the benefits? How does the system ensure consistent grades throughout? And most importantly, why CAD grade control and not any other branded technology systems? CAD grade control is factory integrated. Its functions are fully integrated with machines' displays and joystick controls. High quality installs and calibration from the factory, including the usage of our CAD proprietary design position sensing cylinder to ensure robust configuration and highest standard of accuracy. Say goodbye to sloppy after factory installations, untidy loose wires dangling all over the machine, and best of all, these CAD grade control components will be insured under CAD warranty since they are part of the machine. How easy is it for the operator to use our CGC system then? The E-Series excavator includes a completely new graphical display with colored screen and has two dedicated areas for CAD depth and slope. Its icon display in real-time bucket position relative to the target depth, intangible numeric display, and colored light bars. In order to achieve the desired grades, the operator only needs to follow the light bar intensity and beeper sound alarm. Really easy. It also shows the bucket tilt angle. In this case, there is no tilt sensor. Then the bucket angle is based on the machine roll angle so that the operator knows the angle he's shaping. We can now set an upper and lower limit as E warning so that the operator will not leave his boom and stick too high or too low. This is a feature that many of our customers has been asking for. They have been crying out for a system that can help them prevent the operators from cutting through pipes and utilities underground or hitting installations overhead. It is very important to emphasize here that by using the in-cab display, the CAD grade depth and slope not only saves money for the customer due to lower system costs, but also help to save critical space in the cab itself. The 300E display is long and narrow, making it ideal for excavator operator who needs to see as much of the ground area around them as possible. This makes the operator more productive and safer. Safety, our favorite subject. The best safety feature that we can provide is the removal of personnel from dangerous job site. There is nothing safer than that. With a smarter machine, there is no need for grade checker to maneuver in deep trenches right next to moving machine. Looking at the grade checker, apart from the fact that she is working in the weather and next to moving machine, she is more often than not required to climb in and out of ditches just to get the measurement right. In this demo, our CGC machine is relying on the laser transmitter as an elevation reference. So in order for him to carry on to do the slope work, what he is doing now is that is using his remote control to change the grade on the laser to give him the new reference angle for the second half of the works. Question: how is our conventional machine handling the change in grade? She has to rely on her experience, do a rough cut, then get the grade checker to painstakingly measure point by point so as to give her some reference to keep to the grade. We have deliberately included a slope design to amplify the benefits of CAD grade control. Our machines are no longer just the best production machines, but now is able to shape complex design with ease, making our excavators the choice machine for every application possible. CAD grade control is part of our machine key feature and benefit. It is not an option. One key message from us today is to drive home the point of removing idle time at job site. So how often do we see machines ready to use, incurring ownership and rental costs, but placed as standby, waiting for surveyor to do measurement and staking? So allow me to take a minute to illustrate how much time and money is spent on a typical job site on surveying. If we take a look at the screen, the projection screen for an illustration, in order to stake out a straight road profile, we need roughly 11 stakes just to pick up the general profile. And we have to repeat the stake for 50 feet or 10 to 15 meters depending on the units that you're using. Repeat this for every layer and lease. We are not even considering any curves or slope changes. This example is just a straight road. Whether is it 1 mile or 1 kilometer, we can easily require up to 1,100 sticks for this job. So any idea how many times the roads is staked? At least as many times as there are layers of material. After each layer is laid to grade, the survey crew comes back, survey, remeasure and stack sticks to indicate grade for the next layer. 5 to 8 times is very common. And honestly, most survey crew will cheat a little here and there, not placing 11 sticks across the profile. It will be staked in stages, more stakes as we get closer to the finish grade. A lot of contractor users in US a rule of thumb of 20,000 USD per mile for surveying costs. It varies greatly depending the complexity or type of job. Perhaps with a smarter machine, we can reduce the need for physical staking, saving precious time and money on surveying, turning the idle time into highly productive working time. Any engineer by training will be able to tell you how much time, effort, and money is put in to improve an existing product. And the mere fact that we can prove that the improvement is tangible is an achievement in itself. Therefore, I am very proud to be part of an organization that believes in continued R&D and improvement to the existing machines and systems. Taking fuel efficiency as an example, the R&D, continued R&D on existing design and technology on an engine will reap benefit of 2 to 8%. So a good example from Caterpillar would be the Tier 4 engine enhancement, and out of the box, revolutionary design change to individual machine component design can get improvement of 10 to 25%. A good example will be our hydraulic hybrid excavator, which help us save up to 25% in fuel, given the same amount of production. But when we connect the dots with CAD Connect, with systems from Link, Grade, Compact, etc., combining smarter machine controls with advanced fleet and project management, we can easily create a collective savings of 25 to 400% at the job site level. And all these examples that I've quoted are based on existing product offering, not future products. Even with our naked eye, we can see that the cat grade control trench is a lot smoother over the other. Our operators have done a good job in achieving the grade even without the aid of technology. But another question remained unanswered. Can this operator continue to achieve such high quality standard for an 8-hour workday? With cat grade control, we can remove the risk of fatigue, ensuring highest quality output in every pass.